Take a look at this table. Group B has more yeses, so it feels higher. But the SAT asks, out of what? Compare yes rates, not counts. Before calculating, define the denominator. Relative frequency uses a total. Conditional probability uses the relevant total. On the SAT, choosing the denominator is the decision. Take a closer look. The counts haven't changed, but the meaning might. Because meaning depends on what you divide by. Same counts don't guarantee the same meaning. Now the question changes. Which total should you use, row or column? That depends on the condition in the question. On the SAT, the condition tells you the denominator. Now think about independence. Compare the yes rates in Group A and Group B. If the rates change, the variables aren't independent. Independence is about whether the ratio stays the same. Now comes the ratio trap. Looking at the overall table, one group seems better. But within each group, the rates tell a different story. Same data, different ratios. On the SAT, confusing these viewpoints leads to the wrong answer. Now let's try a practice question. Take a look at the table. Which group has a higher yes rate? Don't rush. Focus on the denominator. Alright, let's go over the answer to beginner practice. Question 1. We're comparing yes rates, not raw counts. So the denominator should be the row total for each group. Group A has 48 out of 60. Group B has 70 out of 100. That means Group A has the higher yes rate. Now let's try question 2. Given a yes, which group is it more likely to come from? Focus on the condition, and choose the right denominator. Alright, let's go over the answer to beginner practice. Question 2. The condition is yes, so our denominator comes from the yes column. We're asking, given a yes, which group is it more likely to come from? Group A has 48 out of 118. Group B has 70 out of 118. So a yes is more likely to come from Group B. Now let's move on to question 3. Are the two variables independent? To decide, compare the yes rates by group. Alright, let's go over the answer to beginner practice, question 3. To test independence, we compare the yes rates by group. Group A has 48 out of 60. Group B has 70 out of 100. Since the rates are not the same, the two variables are not independent. Now let's move on to the intermediate practice. Given a student is from Group B, what is the probability the answer is yes? Fix the group first. Alright, let's take our time and go through the answer to the intermediate practice step by step. First, listen carefully to the wording of the question. Given a student is from Group B. That phrase, given a student is from Group B, already narrows our focus. We are no longer looking at everyone. Before thinking about yes or no, we must fix the group. Once Group B is fixed, the denominator must come from within Group B. This is a row-based condition, not a column-based one. Now read the question again with that in mind. We're asked for the probability that the answer is yes. So the real question becomes, within Group B, how common is yes? This is where many SAT mistakes happen. Students see the word probability and jump to the yes column. Others see the word yes and forget to ask, given what? But the SAT is precise. The condition always comes first, and the condition chooses the denominator. Because the condition is Group B, the denominator is the total number of students in Group B, that's 100. Not the total number of yes answers, which is 118. Not the overall total. Once that denominator is chosen correctly, the calculation itself is simple. Within Group B, the number of yes answers is 70. So the probability is simply 70 out of 100. And that's the key lesson here. The SAT is not testing how well you calculate. It's testing whether you have the discipline to let the given condition choose the denominator for you. Now let's move on to the advanced practice. Using the same data, answer two questions. Which group has a higher yes rate overall? And which group has a higher yes rate within each group? Be careful, you'll need to compare different denominators. Alright, let's carefully go through the answer to the advanced practice. This problem asks two different questions using the same data, and the key idea is that each question uses a different denominator. Let's start with the first part, the overall yes rate. When we look at the entire table, we are treating everyone as one group. That means we use the grand total as the denominator. In other words, we compare the total number of yes responses to the total number of observations in the table. This gives us the overall yes rate. Now, the second part of the question asks something different. It asks about the yes rate within each group. Here, the condition changes. We are no longer comparing everyone together. Instead, we fix each group separately. For Group A, we use Group A's total. For Group B, we use Group B's total. These are row totals, not the grand total. And this is where the ratio trap appears. The same counts are used in both cases, but the meaning changes because the denominator changes. One comparison uses the entire table. The other comparison stays within each group. Neither approach is wrong. They simply answer different questions. And that is the most important lesson here. On the SAT, the mistake is not in the arithmetic. The mistake is choosing the wrong denominator because you didn't notice how the question changed. Let's wrap up this lesson with a few key takeaways about two-way tables. First, remember this. Counts do not tell the story, denominators do. Looking only at raw numbers can be misleading. What matters is what you are dividing by. Second, always identify what is being conditioned on. Words like given, from, or within are not just extra details. They tell you exactly which group defines the denominator. Third, be clear about the type of comparison you are making. Overall comparisons and within-group comparisons answer completely different questions, even when the data is the same. And that leads to the final takeaway. The same data can lead to different conclusions if the denominator changes. On the SAT, mistakes rarely come from difficult calculations. They come from choosing the wrong denominator because the question was read too quickly. Slow down, identify the condition, and let that condition choose the denominator for you. Do that consistently, and two-way tables become one of the most reliable scoring opportunities on the test.